Alright, here we are on lesson 4, identifying proportional and non-proportional relationships in tables. So we are going to combine lesson 4 with part of lesson 5, so we're going to kind of jump around a bit, so make sure you're always on the right page. We are going to start on this page, and we're going to do this first example here. It says, you have decided to walk in a long-distance race. There are 2 teams that you can join. Team A walks at a constant rate of 2.5, oh, that didn't work, miles per hour. I meant to highlight. Miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. So it says to create a table for each team showing the distance they would walk for the times of 1, 2, 3, 4, 5, and 6 hours. So we're going to use the table. So first I'm going to go ahead and I'm going to label time is going to be X and distance will be Y for both of them, because that'll come in handy later. And then for time, I'm going to fill in 1, 2, 3, 4, 5, 6 for both. 3, 4, 5, 6. Alright, so it says Team A walks at a constant rate of 2.5 miles per hour. So that means for hour 1, it's going to be 2.5. For hour 2, it would be 5. And then we would have 7.5, and then we'd have 10, and then 12.5, and then 15. So you can see here, as we're going across, we're multiplying by 2.5 every time. All right, Team B is a little different, though. It says Team B walks 4 miles in the first hour, and then 2 miles per hour every hour after that. So that means we're adding 2 every time. So we'd have 6, 8, 10, 12, and 14. So we're adding 2 as we go down. So now the question says, for which team is distance proportional to time? So we could probably see as we're filling it in that it is Team A. And that's because we are multiplying by a constant the entire table. So because we are multiplying by a constant. And then the next part says explain how you know the distance for the other team is not proportional to time, and it's simply because we are not multiplying by a constant. Alright. So that's all for that page. So make sure you have all that written down. We're now going to skip the next page. Alright, so don't worry about page 11. We're going to skip page 12 as well. Alright, and we're going to go all the way to where it says lesson 5. So lesson 4 is pretty much just deciding if it's proportional or not, and we've been doing that for the last few lessons. So we're going to look at lesson 5, and we're going to look down at the bottom of the page. I'm at example 1. And it says from a table to a graph. So it says using the ratio provided, create a table that shows the money received is proportional to the number of candy bars sold, and then we're going to plot the points. So we see here that the ratio is 2 to 3. So that means our next line would be 4 to 6, and then 6 to 9, and then 8 to 12. Alright, we're using that initial ratio of 2 to 3. So now it says that we need to plot the points. So X is candy bars, so of course we need to label. So X will be candy bars. Remember, the X is horizontal here. And then the Y is the vertical, and that's going to be money. So now we're going to plot the points. So our X value for candy bars is 2, so we go over to 2 and then up to 3. So 2, 3, there's our first point. And then we have 4 and up to 6 here. And then 6 and up to 9. And then our last one would be 8 and then up to 12. Alright, so then we need to connect our points here. Trying to make it as straight as possible. And put an arrow on the end because we know that that can continue on forever. Alright, so that's all we had to do for this example. But if you flip over onto the next page, alright, we're going to use this now to determine proportional relationships. So in the box where it says important note, it says characteristics of graphs of proportional relationships. So you need to write two things. It must be a straight line, and it must go through the origin. So remember, if we go back to our example from the last page, you would see that it is a straight line, and it does go through the origin, so we could say that it is proportional. Okay, we're going to look here at number 2, where it says first to graph the points from the opening exercise. So we're going to have 2, and then up to 3, and then 4 up to 6, and then 8 up to 12, all the way up here, and then 12 all the way up to 14. Alright, so we do have to connect our points. I think some of us can see that this is not exactly a straight line. Alright, so we need to determine if it's proportional or not. We know that it does go through the origin, but the line isn't straight, so that means it's not proportional. So we would say not proportional. And you would say it doesn't form a straight line. Alright? So that's why it's not proportional. There is one more example here. I want you to try this one on your own. So we'll start right on your own. And then we will go over it in class tomorrow. So go ahead and do that, and then we'll go over the answers when we see each other in class.